Friends, this question from Quiz1 25th February 2024 software testing question paper 1. Consider the control flow graph CFG. G is a graph. Control flow graph represented with G is a set of vertices and edges V and E, where the set of vertices are 1, 2, 3, 4, 5, 6, 7. There are 7 vertices and set of edges are 1, 2, 2. So there is a set of vertices given in the question, and the initial vertex is 1 and the final vertex VF is 7, V0 and V7. For this question, what is the minimum number of test cases? I think these are test cases or test paths, I don't know, but these are test paths to be prepared for the node coverage, that is node coverage, and the edge coverage EC. So what is the minimum number of test cases to be preferred for the node coverage and edge coverage in a given control flow graph? So there are 4 options. So which option is the correct for this control flow graph to cover the node coverage and the edge coverage? So for this, first we draw the control flow graph. So he mentioned the initial vertex is V0, right? So this is the first initial vertex V01, and there is an edge 1 to 2. So 1 to 2 an edge, arrow direction is there, and 1 to 6, and 1 to 6 there is an edge. So these are level 1. Okay, all these are level 1 edges, that is one node 1 to next node are level 1 to 6, and 2 to 3 this is next level 2 to 3 edge, and 2 to 5 is also there, 2 to 5, and 3 to 4 this is next level 3 to 4 direct edge from 3 to 4, and 3 to 5. So 3 to 5 there is an edge, and 4 to 3, so this is a back edge 4 to 3, and 5 to 6, so this is the 5 to 6 edge back edge, and 6 to 7. 7 is the final vertex, final vertices vertex. So VF, there is an edge from 6 to 7 given control flow graph. So for this, first we want to find the node coverage and the test paths which cover the node coverage and the edge coverage. So what is the node coverage? Node means what are the number of nodes? There are 7 nodes, right? That is number of vertices given in the question, that is 7 vertices. So is there any test path? It covers all the 7 nodes. We will check. Okay, there is any test path which cover all the nodes, that is node 1 to 7, that is we cover all the nodes. This is the node coverage. Node coverage means in the control flow graph it will cover all the nodes. Okay, there is no need to write like this. 2 to 2 is not correct. So there is an edge from 2 to 3 and edge from 2 to 5, right? 2 to 5, that is here 2 to 5, not 2 to 2, 2 to 5, sorry for that. So there is an edge from 2 to 5, not 2 to 2, right? So because of that I write the 2 to 5 edge. So what is the question? What are the minimum number of test cases, test path required prepared for the node coverage? First we will check the node coverage. Node coverage means in the control flow graph it cover all the 7 nodes. There is a test path. If there is any test path TP, it covers all the nodes, that is given all the nodes 1 to 7. We will check. Okay, for the test path 1 to 2 there is an edge. Okay, 1 to 2 there is an edge. Next 2 to 3, 2 to 3 is also there is an edge, and 3 to 4 there is an edge. Okay, what are the valid test path? Test path starting from the start node, that is 1, and ends at the final node. Okay, final node. We will check 4, and we want to go 5, right? We want to cover 5 also. that is go to 4 to 3, that is 4 to 3, and 3 to 5, and 3 to 5. Okay, 3 to 5, and we want to cover 6, right? 5 is covered, 6, so 5 to 6 there is an edge. Okay, we will go 5 to 6, and 6 to 7. Okay, it covers all the nodes, right? It covers all the nodes, and this is the final vertex. So is this test path is valid? Yes. Is this test path is valid? So is there in the direction is from the node 1 to node 2 is valid direction? Yes, valid direction. There is a path from 1 to 2, and 2 to 3 is a path, and 3 to 4 is also valid path, and 4 to 3 is also valid path, and 3 to 5 is also valid path, right? All these directions are valid directions. That is, this test path is valid because valid transitions. In the control flow graph, there is a arrow direction present between the every edge between the nodes present in the test path, and the test path must end with the final node and start with the initial node. Is this correct? Yes. 1 is the initial node and 7 is the final vertex. So is a valid test path? Yes. So there is one test path is required to cover the node coverage. For cover the node coverage, it will cover all the nodes in the control flow graph. So which options contain the one test path? So it is 2 for node coverage. It is wrong, right? It is 3 for both node coverage and edge coverage. So not 3 for node coverage. This is one path, that is one test path for node coverage. This is the correct option. But option A also has one test path for both node coverage. Okay, so we will check for edge coverage also. So first we write the what are the edges. Okay, so no need to write the edges. Edges given in the question, right? So here, so edges is given, no need to write again. Okay, these are the edges given in the control flow graph. So we will write the one by one test path. So for first test path, 1 to 2 is there is an edge. Yes, 1 to 2 this edge is covered, right? 1 to 2 this edge is covered, and 2 to 3, yes, 2 to 3 this edge is covered, right? 2 to 3 an arrow, 2 to 3 is an arrow, this edge is covered. Next 2 to 5, it's not possible, we are from 3, right? We cannot go back to 2, so it's not possible 2 to 5 covered. Okay, because there is no backward edge in 3 to 2. If 3 to 2 backward edge is there, we will cover 2 to 5 also. Okay, only 2 edges. After 2 to 3, 3 to 4 we cover. Yes, 3 to 4 is also covered an edge. 3 to 4 we will go back to 4 to 3. Okay, 4 to 3, 4 to 3, 4 to 3 this edge is also covered. This edge is also 4 to 3, and 3 to 5, 3 to 5 this edge is also covered, right? 3 to 5, and this edge is 3 to 5 this edge is also covered. All these red color edges are covered. After 5 to 6, okay, 5 to 6, 5 to 6 this edge is also covered, and 6 to 7, 6 to 7, 6 to 7 these edges are also covered. So how many edges are it covered? 1 2 3 4 5 6 7 edges. That is 7 edges covered by this test path 1. For example, this is test path 1, TP1. Okay, so rest how many edges are left? 2 5 is left, right? 1 6 is left. 2 edges are left. So we want another test path, that is test path 2. It will cover 1 to 6, right? So there is a test path, so 1 to 6 1, right? This is also starting with initial node, is ending with final node. This is a valid test path. So in the same way, test path 2 starts at 1 initial node, that is starting node is 1. Okay, 1 2 6 1 2 6, this edge is also covered. Next 6 to 7, right? 6 to 7, because that test path ends at the final vertex only. Okay, this test path covers only one edge, that is 1 to 6. This edge, blue color, this sky blue color edge is covered. So how many edges are left? 2 5 is left. All edges are covered. So 7 total. This test path covers test path 2 1 edge, and test path 1 covers 7 edges, and the next one want to cover. So this edge, right, 2 to 5 is not covered, so this one 2 to 5 is empty. So test path always starts at the initial vertex, start vertex, that is 1. Okay, that is we want to cover this one, right? We will go this direction, 1 to 2. So that is 1 to 2. Next 2 to 5, 2 to 5, this edge is covered. Yes, this edge is covered. Yes, covered. 2 to 5, 2 to 5, and test path must ends with final vertex, right? 5 to 7 there is no vertex, so we will go back 6. Okay, 5 to 6, 5 to 6, and 6 to 7. Okay, we will reach the final vertex. This is the test path, this is the final vertex, this is the initial vertex, this is a valid test path. So test path condition is valid condition. So test path 3 will covers the so many edges, but mainly it covers 2 to 5 edge, 2 to 5 edge. It covers 1 to 6 edge. Rest all are covered by first test path 1. So it requires 3 test paths to cover the edge pair edge coverage, not edge pair, edge coverage only. Edge pair means 2 edges, only edge coverage, EC, edge coverage, not edge pair coverage. So it required 3 test paths for edge coverage and 1 test path for node coverage. It will cover all the nodes. Okay, so for this question answer B is correct. Answer B is correct. In the same question they are asking what is the cyclomatic complexity. This one, what is the cyclomatic complexity of the given control flow graph. So generally there are 2 formulas for cyclomatic complexity. So cyclomatic complexity equal to number of decision nodes plus 1. This one easy to find from control flow graph, it is given. Otherwise in a single connected component, so the single connected component, that is entire control flow graph in only one component. If there are 2 components, both are connected to each other. So in this control flow graph is in a single connected component. The cyclomatic complexity CC equals to, so that is number of edges, that is absolute value of the edges minus absolute value of the nodes, that is nodes minus vertices, edges minus vertices plus 2. You can use any one, you will get the answer. Okay, what is the D? D means decision nodes, number of decision nodes, number of decision nodes. So this is the node 1 is the decision node D. Why? So there is 2 nodes, right? Decision means if condition or anything, conditions are there, it splits into 2 nodes. Generally it splits into 2 nodes. These are the decision nodes. So here node 2 also 2 nodes, right? This is also decision node. Again 3 to 4 is also arrow, I forgot it. 3 also decision node. 3 also decision node. Here it splits into 2, right? Splits into 2. That is if condition or else condition. if else condition. 3 decision nodes, that is cyclomatic complexity equal to d plus 1. D are 3 plus 1, that equals to 4. This is the cyclomatic complexity. Answer for this question is 4. Or by using this one, right, C equal to number of edges, E minus vertices plus 2. So number of edges, how many edges? 1 2 3 4 5 6 7 8 9. 9 edges. So edges 9 minus vertices 7, right? 1 to 7 plus 2 plus 2, that is 4. So both are same, right? So the answer for this question is same. Anyone you can use, but be careful in a single connected component. The control flow graph must also always present in only one component if you apply this formula. Okay, 6 to 5 to 6, 2 to 5, 2 to 5. And friends, I forgot 5 to 6 is also another edge, right? Another edge, 5 to 6. But it does not change the decision nodes, but these are opposite direction, right? In the node 6, these are in the opposite direction, so it will not affect the cyclomatic complexity. Only 3 nodes are decision nodes. It's not, 6 is not the decision node. The arrows are in opposite direction, right? Because of that, 6 is not a decision node. Only 1 2 3 are the decision nodes. Sorry friends, I forgot to add the edge from 5 to 6. Thank you for watching.